I always wanted to give the introductory speech, but yesterday there were not so many people at the beginning, then everything was already in the middle, and that wouldn't make much sense to introduce you to what is happening here. And the same actually is happening today. So at a certain point I really wanted to give the intro. Sorry. So I will make it very briefly now. The reason why I even organized this event was that I see that many people are doing something that is similar to what I'm doing, what we are doing here, what I would like to do, and it always makes sense to just meet and discuss things. And I have a lot of things in my mind that I would like to discuss with these people that I invited. And also, we made it public because that worked also in the past for me. Some of you might know I've started 5 years ago with a brand that is now called Research. And it started as an architecture theory platform, so it was not really related to anything digital per se. But basically I wanted to conduct my own research that was similar to some kind of dissertation or something, but I didn't do it at any institute. I was doing it on my own. But then you cannot sit at home, read books and write papers and have no feedback. So I started organizing lectures, actually more debates, because I wanted to meet certain people that I knew they are here and that could help me with my own research, with my own thinking process. But there is, I felt a bit awkward just inviting them for a beer. So I started organizing public debates. And basically I gathered 3-4 people. They were sitting in front of an audience, slightly bigger than this one right here at the moment, but it gets better. And we were talking for 2 hours about stuff that I was interested in. And the project back then that I wanted to research later on showed up to be kind of naive. But then I'm coming back to it right now, and that's why I'm talking about that here now, because I again want to discuss the same project that I had 5 years ago, 6 years ago maybe. And that's why my talk is going to be slightly more personal than the previous talks we saw yesterday. They were incredibly amazing, very professional. Mine is not that much. And this is the background for the entire event that is happening now. And that's also the background of my own research. Basically, I was studying at the Technical University here many years ago. And I was struggling. I was not the best student because I never understood the logic behind designing architecture. And I tried with 2 more universities after that, and it helped a bit, but I really couldn't find what is it all about, because mainly I didn't understand how the decisions are made in architectural design process. And that is the background. That is a very personal background. I had to investigate the methods of designing and creation of architecture, mainly to understand what is going to lead my decision process. And what I was taught and what I was doing for a long time, by the way, I'm not showing that many pictures. I will show a couple of them. But when I was organizing the debates and lectures back 5 years ago, I was forbidding the speakers to show any pictures because I thought it's much more important to talk about the concepts behind rather than just showing the work. And I was very pleasantly surprised because it worked all the time pretty well. So I hope you wouldn't mind that there's not that much visual material. Anyway, when I was still working as an architect and when I was a student, I probably wasn't a very smart one because I saw that the architectural design process is based on goals. I just call it goals. What I mean by goals is that you first have a moment of inspiration, or you have an idea of the final result that you want to make, something that should be the product of your design process. And what people are doing, what I was doing is I was finding ways to achieve the goal. So it is obvious that there are many ways how to achieve something, but the most important notion here is that I always had the idea of the final goal somewhere in my imagination. I was just trying to find ways to achieve it. When I think about mechanics, I always have to find examples from the real life to explain the way of thinking. So when I'm thinking of the mechanics, it is like if there was an engine somewhere far away and there was a string attached to the engine and the engine was pulling myself towards itself, which is the goal. So I'm getting pulled or attracted to the final goal, to the final product of the design process. And this is something that that didn't work for me because there was so many arbitrary decisions and so many unknowns in the goal that I didn't know how to actually grasp it at all. But in fact, these are not the ways to achieve the goal, are not what actually drives the design process. This is something, the goal is driving the design process and it's attracting you as a designer towards the goal. So if you remove the goal, these arrows don't make any sense because they are just a ways of achieving one particular thing, and that particular thing is not described by those ways you achieve it. On the other hand, I started investigating a bit, well, investigating, you don't really have to, you just have to understand a bit, how does the nature work, how does the evolution work, and that was my very first lecture I ever gave in Brno in 2010, I think. And I was somehow trying to explain that it would be more than cool to get inspired by the evolution as it works in the nature in the design process. What is very important at this point is that the final product of creation, whatever it is not pre-designed in advance. It is a result of many forces that somehow in a certain point in time result into something that is not a goal but a result. So we've got two opposite states. One is designing using the goals that you already have somehow in your imagination. The other one is a result of some forces and you are actually thinking of the forces. And at that point I wasn't really sure what the forces could be, and I still am not sure. But this is the duality. So you either have a goal, or you are finding ways to achieve the goal, or you have the forces that are somehow influencing the creation process, and they result in something. Very often it doesn't result in one static or one stable harmonic state, but it's a process that can be evaluated at any point. At that time, I thought that evolutionary algorithms would be a great way of simulating or at least investigating on this. I don't think that anymore, because the way the evolutionary algorithms are designed now, they're mainly optimization methods, and I'm not really that much into optimization. But only recently I was, well, as I said yesterday, I will somehow show that I will try to explain that I don't like the way the things are being done conventionally, which in other words means that I would really like to propose a new method of creation rather than a pure continuation of what we had in history. Mainly in modernism, because that's what took over the whole architectural scene since the second half of the 20th century. It seems like there is not much more than modernism and functionalism and international style. But when I was preparing this presentation, and this is some kind of a fresh thought, I was actually thinking that there is a couple of really interesting things about the conventional method of designing, and also these things are not suitable for myself. So if we talk about the goals, and if we talk about how do they actually work, so if you have an image of a final object in your mind, you have to, it's probably not random, and you probably have certain intentions when you were designing that, and you were implementing those intentions into the final thing. And you always try to find a linear way how to actually achieve those intentions that are implemented in the design. So actually, when when you design conventionally in a linear way, what is quite interesting and nice is that all the intentions, including the design, including the performance, it is embedded in the object. So the object is everything at the same time. It is the intention, it's the implementation of the intention, it's a form that the intention takes, and it's a technology, so everything is in once, which is quite nice, but it takes a lot of patience and a lot of talent to actually be able to handle so many different things in one object of creation. And I don't have any of those. I don't have patience, I don't have talent, I don't know how to evaluate aesthetics properly, so this is not suitable for me. What is, on the other hand, suitable for me is thinking or working the way the world and nature works, which I will come to a bit later, and it's the result-based design, which is, in fact, it's the nonlinear design. That's something that I, of course, haven't invented, that's been around. But if I make the same analysis of this result-driven or nonlinear design, what is the difference is that you basically, at the beginning, don't really have intentions, but you've got forces that are leading to the result, which is much closer to the true nature of the object that you want to create. When you think about architecture, you might see smart solutions for certain problems, but the designers usually are looking for implementations of that solutions. However, you might just make the intention or problem or a solution as such, you can call it a force, and whatever results in the final form could be emergent. So in the nonlinear design, the implementation is emergent. It's not embedded. It's not really part of the design. What you can design, though, are the forces that are producing the final result at the end. So when you have a linear design process, goal-oriented, then all the things are embedded. Idea, intention, and implementations, all of them are embedded in the object. However, if you go in the nonlinear way, when you think about the forces that are creating the object, then you have separated the idea, then you separate the intentions, and you somehow create, those are the forces that are creating the object, and the implementations, that just happens. You don't necessarily need to have the talent to make the implementation, and I certainly don't. It's not only that, if you, as a human being or as a team of human beings, have certain intentions, how many can you handle? Can you handle 5? Can you handle 100? Maybe 1,000? But if you want to implement more intentions or more forces than that, you certainly need to use certain automatic process, and that's what the computers are great for. In this picture, well, in the name of this gathering, I wrote something like a shift from biomimetic to morphogenetic, and this is just another thing. I'm now in the digital domain, and what I see very often, and what I do personally sometimes when I lose it, is the biomimetic approach, which means that there is some natural or bio-inspired either method or form or solution to something that is trying to look like something that you can find in the nature. And many designers are trying to achieve that using computers, or at least to get close. And that is still a linear process, because you still have an intentions, you still have an idea of the goal, where you're actually going, and you just try to go there somehow. And the fact that we are using very advanced computational methods doesn't really mean that we are working in a morphogenetic way or nonlinear way. A nonlinear, actually force-driven way. However, the morphogenetic approach is the one that you let some forces generate or create the final form, and you're not really interested in the form itself, you're interested in the forces that are creating the form and the reasons why the forces are creating the form. And that's where we are coming to the swarm behavior, because when you have swarms, the swarms can actually simulate many things, and they could probably simulate the forces that are creating the forms. And we are back to this. So the arrows now would be the forces. You can think about them as agents or multi-agent system or swarm system, where the little agents are having what they stand for. Actually, the agency, the English word, to be an agent, to be a representative of something, it actually is a very appropriate name. So if you think about it, the agents could stand for something, for some ideas, not really only for a simulation of birds, for example, but they can really stand for architectural ideas. And those architectural ideas would somehow result in the final object of creation. What happened to me, or what I was doing, and now these are the very few pictures that I have. What I ended up doing before I went public with these things, I was really trying to find architectural ideas that could be embedded into or implemented into a swarm behavior or any kind of automated computational behavior. And I was reading through Peter Eisenman's books, and he was elaborating on the fact that the modern visual arts or fine arts are being somehow self-referring or self-similar or self-oriented. And I really liked the idea, and I just opened Grasshopper and I did something that I hoped would be self-similar. And I was really not intending to create a fractal, but I ended up creating this Julia set. So I just saved the file, rendered it, and I kept it for a while, and never published that. Well, I did publish it much later. And I realized that if I really want to have architectural topics, and maybe even formal architectural topics or artistic concepts behind this big project of morphogenetic, automated agent system creation in architecture, I really have to investigate first what those intentions or architectural, even formal things could be. And I always try to somehow link it to some existing theory of architecture. I still remained at the Peter Eisenman's self-similarity or self-affiliation in this case. I wanted the agents, let's call them agents because they are, I wanted them to somehow react on themselves. So again, I was trying to somehow fold the logic inside, inwards, to make it self-created. I'm pretty sure that's, well, I think that could be probably what Patrick Schumacher is talking about when he talks about autopoiesis. I am not really sure because I wasn't patient enough to read through the entire book, but I hope I will do it at a certain point, I promise. Again, I ended up doing something that is quite usual, and that's what many people are doing, and this is, I ended up making some stigmergy here. Because stigmergy is that the little elements are somehow reacting or just following themselves. At this point, well, I've got a couple of other examples. This one is an emergent form. This is my take on the what I didn't know at that time would be diffusion limited aggregation. But this really shows, and I didn't know what will be created. I just had some random growth at certain points in the geometry because I wanted to know if it's possible to somehow use the internal forces that I described in an object in a geometry to actually make the object grow. I ended up having this kind of a thing, I call it a freak, but there was absolutely no design intention. I didn't know that it will create these legs and nose and arms and many arms. There was absolutely no design intention, and again, this was created, and I'm using this picture to demonstrate that even without the idea of the final result, you can create something that can be evaluated as a design object. And then I wanted to be a bit more consistent in the design process, so I call this temporal aggregation, which basically means that I wanted to show and demonstrate at one of the workshops that you somehow need to take a different approach if you want to use an additive method within a time. So in this object, I kept adding curves on each other, but that is not possible to do in one step. So you need to keep adding them one by one so that you can keep adding them on top of each other. So this cannot be done in one step. And again, this is more a design idea rather than just an idea of the design process. So yet again, very small project, and I never really used it for any bigger purpose. But this is another example of how to use architectural thinking in very little projects that I very seldom finish. Then I was actually very curious. I saw that people were using Game of Life for as a design process, and I cannot really imagine what that would be good for, because it doesn't make really much sense to me to use Game of Life as a design tool. But then I was thinking that's a very rigid algorithm. So it is a cellular automaton that has very strict rules. And I was thinking, what happens if I break the rules just once? So what you see here on the left side, that's the pure Game of Life visualized. In the second run, in the second pillar, you see that in the second iteration, I just embedded one error, one single error, and then continued without putting any errors. And the third column is I'm only visualizing differences between the pure Game of Life and some kind of broken Game of Life. And I was very surprised that it actually results in a lot of difference. So there is the butterfly effect, and I somehow was curious whether it has the ability to heal itself. So I really expected that it will become very similar to the non-broken Game of Life. And this is not about the Game of Life. This is about how does a little error in the design process influence all the other steps that you have if you work temporarily. And I, of course, ended up realizing that if I really want to embed or use or apply a lot of architectural thoughts at the same time, I probably shouldn't be using genetic algorithms because they are meant for optimization, and I'm not really that much interested in that. But what I should be using are complex systems, and then also swarm behaviors. But the agents shouldn't really stand for something that is inspired from nature. We don't really need that. I know that mathematicians are using them for as search engines, but what I really think we can do as architects, designers, somehow artists, or people who deal with culture, we can use complex systems to simulate artistic approaches, and many of them at the same time. Or if we really want to be reasonable as architects and do something really functional and useful, we might use program and flux intentions as the forces of the creation of architecture. And that's what I started calling design by behavior, because if you know how does your final creation, how it should perform, actually not really how, but what kind of tasks it should, or what kind of intentions and forces and content elements it should have, what you can design are these things. Like, you know that a building that you're creating should be cozy, warm, and easy to navigate. Therefore, you don't need to look for an implementation of these things, but rather you can just make these things create your architecture. But basically, I'm not really interested that much in these functionalistic or modernistic takes or wishes for architecture. But I was really trying to find something more architectural, more related to the meta level of architecture. And I think that what we can start designing is the behavior of the agents in agent systems, and the agents could stand for something valuable rather than a simulation, or architecture rather than a simulation of nature. But because I was making these little experiments on my own, just trying to figure out how can I only operate on one architectural or formal idea, I realized that we cannot really take this big leap from what we have now to something that is completely different. And it's not because the society is not ready, it's because I personally am not ready, because I need to make these little steps first and somehow teach myself, but also other people to think that way. And I realized that the best way of doing this is to exploit what we already have. And if you want to teach somebody complex systems, then the easiest thing you can do is you can just show them Reynolds boids because they are easy to understand. It's a simulation of a flock, and I decided I will just make it available for Grasshopper because at that point in time it was finally possible to implement that, and I wanted to do it in the most understandable way in the Grasshopper logic. So I created the Boid library that actually works with vectors, and my sincere and original wish would be actually this. When you use Voronoi pattern in Grasshopper too much, you get this picture that is telling you that you shouldn't be really overusing it because that's not a cool thing to do. And I really want someone at one point to do something similar to the Boids, because I'm trying to push them everywhere so that people understand what the complex systems are and what are the multi-agent systems. When I go back, there was this blog post by Marius Watts who says that the Voronoi is off limits until 2015. By the way, it's allowed now. It got used way too much by architects in 2011. I remember it from much earlier too. Temporarily banned algorithms, he actually names a couple of more. Unless you make it rock, stay away. And if you don't think an algorithm can rock, we have nothing to talk about. And I really like this because he's not saying that you shouldn't use Voronoi. He says you shouldn't use Voronoi just as a pattern. You need to understand and you need to make it rock. So what I want to achieve is please overuse the Boids, overuse the flocking or swarm behavior, so that you finally understand what is it all about, and then we can start simulating something more sophisticated than just the flocking birds, and we can do something more. And I created a lot of experiments using my Boid library, and I'm trying to teach it everywhere because I want it to be overused. I only have 3 minutes left. I'm a bit too long. But I'm also trying to tackle these topics from different positions. And this is a project that I'm not showing that often, but I'm kind of proud of it. I was invited 2 years ago, more than 2 years ago, by a friend of mine who is an artist, and he was supposed to teach a drawing workshop, a plein air, like using real paper and pencil workshop. But he wanted to make it processual. He called it processual. So he invited me to do it with him, and I really cannot draw. But I created this processing program, and I've got some screenshots. This processing program was doing these things. On the left side, you had one window in which you could have either a camera switched on, or you could import a picture, or you could draw directly to that little window. And on the right side, the computer, the program was trying to resketch whatever you were sketching. And I was not telling the students, the participants, what is it all about. And it somehow even was distorting what you were drawing on the left side as well. And I was not telling the students what is it all about. I wanted them to figure out what is actually the result. So you can think of many results. You can think that what is on the right side is going to be the result of the process. Or maybe your interaction on the left side, trying to achieve something on the right side, would be the output. Or something together. But what I meant to do is I wanted to have a very small agent system. One agent would be the artist, the other agent would be the tool. I wanted the tool to become one of the agents in the creation process, and this is one of the outputs. One of the students, she tried to explore all the possibilities, and she created something. And I was really very proud to see what they have made, although they didn't like the workshop at all. But still, I was promoting some kind of idea. And I do promote these ideas a lot, and we are being hyperactive here with the brand research. We have the debates, we have the live workshops where I'm inviting people, and I really always wish for them to show the same agenda. We're having the Grasshopper Sessions, the online teaching, where while just making tutorials for Grasshopper, I'm always trying to put in little hints in the design, and I wish that people would somehow grasp it as well. We have the KUKA Lab that Tomáš was talking about yesterday, and Stuart is going to talk about today. And this is the meetup, and this is just genuinely about this topic that I mentioned. What I'm looking for in the speech is is this kind of an approach. I'm looking for people who have similar approach to using the existing complex system algorithms that are around. And I have 4 seconds left, so there is no time for something completely different, but I have a couple of pictures there as well. So that's it, half an hour. Thank you very much. And because I'm the host at the same time, if you want to ask me something, we have 10 minutes to discuss. This never happened before. Everybody got a question, but me. Should I go for something completely different then? Yeah, okay. This will be pretty short, but that's really something completely different. I believe what we are doing, or once we start doing it really properly, we are going to have a lot of problems with the discipline of architecture. If you are designing the way I'm proposing, if you're building structures using rapid prototyping, robots, 3D printing, you will have a lot of problems with legislation and bureaucracy. You will have a lot of problem with the critiques because they wouldn't be able to read what you're doing. You will not probably fulfill the standards and norms, or if you do, it will restrict your design approach significantly. What I think has to happen is that it's either them or us. And I'm not calling for a fight. What I want to say is that we have to admit that one of us, either them or us, is not doing architecture. And I think the easiest thing to do is, if we are going to, if we want to have the freedom not to be restricted by the rules that exist for architecture, it could be quite smart not to take over architecture, but to admit that what we are doing is not architecture, which gives us a lot of liberty, because when you want to build something in real life, you are not claiming it's architecture, and then the architectural regulations are not going to be a problem. But what happens is, if we just flood the world with creations that we are able to produce right now, somebody will have to figure out what to do with them. So they will qualify it somehow, they will find the rules for us. It will happen, and it's a much easier approach than trying to say, this is the new architecture, and you should see it differently, and you should evaluate it differently, and the legislation and bureaucratic rules should be somehow specially made for this kind of architecture. So what I'm trying to say is, maybe it's easier to say that we are not creating architecture at all, and we will have much more freedom then. And somebody will figure out where to put us, into which box we belong, what rules we should follow and obey. That's something completely different. I'm thinking it's easier in this world to do it this way. And also, I don't want to really lose the existing architecture as it is. I think it's important. Therefore, it might be smart to make a step sideways. That was something completely different. I hope somebody will talk to me some other time.